Well, I hope, there you go. You want me to go this way so they can see you?
No.
Ooh, that was quick.
That is cool.
That was really quick.
That's cool.
It's like one of those little vacuum. Just get a vacuum thing.
Yep.
I don't really like this.
Okay. Anyway, what I would like for you to do is either you or your partner, from your notes yesterday, you can pick something you think will be important to remember as we move on. And come up to the board. Come up to the board to write that down.
Yes, you should.
Do we need these cards? I don't have cards.
It's out of the.
Send you.
Alright, Caitlin.
Cell phone. Cell phone.
Oh.
Cell phone.
If I know, that doesn't fit. That's not how we do it.
How many?
No, I'm not actually.
Wait, can we just write anything?
How many are you writing?
What is it?
What's
I don't know, you can draw the. Orbitals.
What? Dornbos told me to.
Can I draw this?
Yeah.
Yeah. Partner, five.
Maybe like it.
That's stack. Yeah, stack. Stack.
Like the P subshell.
We still got the hang. P has 3 orbitals. That's P said. has
Gosh,
3 orbitals.
dang it.
Yeah, I'm trying.
You write the same thing up there?
No. That's what you were gonna write?
Yeah, we're gonna put the
Because we
P.
have 3 orbitals. Ha ha.
P, what we were gonna write.
So you can come up with something else?
Huh?
Oh, that's
You
bad.
can come up with something else.
Hey, somebody copied me. Who did that? Each level builds on the last. Orbitals all stack on each other. Stack?
Yeah.
Looks like.
Well, yeah. I think they're both good.
They're the same.
Pretty close.
That's good.
Pretty close.
Yes.
Pattern.
Hat.
Pattern.
Hat, like pattern.
Pat?
Right, there's 2 teams,
Like
right?
what?
There's
No, you spelled it right. It's just pattern. That's it.
That's all I get.
Okay. Let's go ahead and see what you have.
Hey, shh.
You ready? No distraction. 1s, 1 energy level, 2 electrons max. Pattern. Where is their pattern? Everywhere. Where did we see one yesterday?
On the periodic table. It was like 1 and then 2.
Okay, so pattern maybe more specifically on periodic table. Okay. P has 3 orbitals. S has 1 orbital. Orbitals all stack on each other. This is the 3p orbital subshell. Sorry. And there are 1, 2, 3 orbitals in it. Okay, lots of words, yep? Yeah. Each level builds on the last, they all add together.
All stack on each other.
All stack on each other. Some of them, well, all right. 3D orbital.
Important.
It is important. Yep. And also a little tricky, a little unexpected maybe. I'll make you surprised. Each orbital holds 2 E max, and 3D holds 10 electrons total. Okay. Well, think it's time to get your periodic table out. Let's see what you remember from yesterday. Starting, so have your fingers start at hydrogen. I don't know if it catches it or not. Not sure. It's not like this. I think it's pretty good. Very close. Okay, so you tell me. Just a little bit of background. Every atom has a cloud, and the cloud is called an orbital. And as electrons, as like an atom gets more and more and more and more electrons, it gets more and more and more clouds. Okay, so all this is just, we're just naming the clouds as like a type, S, P, D, or F. Okay? So every atom starts out with the basic, smallest, simplest type of orbital. So you tell me what that is. Okay. And then
Two P. 3 P. 4 S. 5 S. 6 S. 7 S.
okay, so back here.
4 S.
Good job.
3D.
Oh, I could not wait.
4 P.
And that holds 6, and then
5 S. 4 D.
good job.
5 P. 6 S. Success.
What is this? Did you crack yourself up? And how about this?
F. D.
It is an F.
F. F1. 4F, 5D, 6F.
We didn't learn it.
We didn't learn that.
Okay, so now here it is. This is 4F and 5F.
Oh no. Why?
4.
So it's even behind D1 then?
Wait, why is it 4F, 5D, 6S?
So then that's 5B then?
Don't make no sense.
What?
So here, hold on. So we're just going literally in order. So this was 6S. And then now lanthanum is a D, okay? So this is only down here as like the parent of its family. So it's a D, but then starts 4F, and it goes all the way, and then comes back to the D block, and it would be 3D, 4D, 5D. Yes,
Does F have 7 orbitals?
it does.
And they're like all 2?
Yep,
Okay.
14 electrons. Nice job.
Wait, how do you know that?
Yeah, what?
Well,
Because there's
times 2 is
14, and then if each one holds 2 electrons, then there's 7 orbitals.
She's basically a genius.
Pretty much.
Okay, so what was this one here?
3D.
Okay, y'all back together. And how about here?
4D. 5D.
6.
Okay, so those are all fine, normal. But once you get here, this is the F block. Here's 4F and here's 5F. Okay?
Wait. So NP isn't part of the F block. Do you have an NP? Are those all both
They
part of
are.
the F block?
Mhm.
So that whole thing is the F block.
Except the parents.
The parent part of it is B block.
Yeah.
Why is 58 4F, 5D, 6S?
The way they list them so that like the ones they put last are the electrons that the element will lose first. So they put them in an order that gives you some information about how they react. You can kind of think of like the ones at the end can be picked off easily. Stolen. Aaron, did you have a question?
Did I?
Yeah.
No.
Okay.
Was he blinking?
No.
No. Grant?
What was made first, the periodic table or periodic groups?
At the same time.
Yeah. What was made
We watched a
first?
video on this. It's called Mendeleev Goes to Space or something. But
Mendeleev goes to space.
finds out this, but
I don't know. He did have a dream.
yeah.
But yeah.
It's the same.
So Grant, your question is what was made first, like these S, P, D, and F things or the periodic table?
Yeah.
The reason the periodic table looks like this is because of electrons. So same time, probably. Yeah, they would have never, like, I think they would have, really what they did at first was just line all the elements up, like from 1 to 92, or whatever they had found. But then what they saw is that every so often, like, similar properties happen, so they thought, well, it'd be smarter to just group those together. Okay, now we're gonna go 5 little, like, see where you're at questions. What would be, so you have to point, get ready. Which element just begins the 4s orbital? So just point before you say anything. Don't say anything out loud. Which element just begins the 4s orbital? And?
Okay.
Okay, potassium. All right. Which element just, or like completely fills up the 3p? Don't say anything. Which element completely fills up the 3p orbital? Okay, what is it? Good for you. Do you have questions at this point?
Why does this matter? What help?
What?
What's it? What's it?
I heard it too.
What's it help?
Yeah.
Okay.
I didn't.
What's it help?
Right. What we're getting to is how tightly atoms hold on to their electrons and how good they are at pulling on other things' clouds. So, and that's called reacting. But you have to know some things about where they are before you figure out what they will do. It's kind of like a metaphor for life, I guess. You have to know yourself before you go out. Sydney?
Okay, so how would like the beginning, would like aluminum, since it's just the beginning of 3p, would it look different than argon then? Because it's the end of 3p, or they still just look the same?
Their clouds will be the exact same shape. Aluminum will only have put 1 electron into the cloud, into the 3p.
Okay, but then there'll be like 6 in argon.
Yeah.
Yeah. Yes.
This is totally random, but why is number 43 synthetic?
Technetium.
Yeah.
There's a T.
Yep.
Technetium.
I think it's silent.
There's no C.
So it'd be technetium.
C, like a S.
There's no C.
Right. So
There's no
you know how
T
like
there.
celebration, like TION. So I think tech.
Celebrate. Shun.
Yeah, I know. It's
Yeah.
TION.
That sound
Anyway, it's technetium.
It's,
That's the word.
so it'd be technetium.
Yeah.
No.
Yeah.
Technetium.
It doesn't have to be a solid T.
Wait, why? So why?
That's my
I'm not
point.
saying so.
I know, but that's my point though, because like it doesn't have to be technetium.
Why isn't it real though?
Why is it synthetic?
Well, it's not. It's real.
Why is it real?
Your clothes are synthetic. They're just. It just means they were made.
It's like man-made. It's
Yeah.
synthetic. Why is it?
Because.
Why isn't there one there?
Is your neck okay? It's like- I don't know. It just is. Yeah, it's a good question.
That's a bad answer.
Yeah, it's a bad answer. I think it just is.
You know it?
Yeah.
It's like, I don't know.
4F and 5F. Oh, wait, what? Here?
No. Lots of
7S,
yes.
5F, 6D, 7P.
And so does that.
Wait, what? Where's 7?
7P.
Oh, where's 7? Oh, the 113?
What is IA, IIA, IIB, IIA?
They're just headings of the columns. 1A, 2A, it's Roman numerals.
No, I know that, but why would it be? Why would it be B or A? Or
The A, like, it turns out that the S and the P, these are the most influential for every single atom as far as like how they will react, and so they kind of separate those out as a little bit more important. It all has to do with electrons, though. They're called the representative
So why
elements.
wouldn't that one be 1B and not 3B?
I don't know.
Because
Yep, I'm not sure. Grant?
So helium is the same group as hydrogen, right? 1s.
Yep.
It's in the same orbital.
Yeah.
Yeah. Okay.
I don't like how they're on top.
Where else would you want to place them?
In a normal line like the rest of them.
Helium's pretty special because the noble gases are over here in a group together because they're the only elements whose entire energy level is full of electrons. Other elements have full subshells or full orbitals, but they have full everything. So like their entire energy level 1 is completely full. Before we're going to like talk a little bit more and get these energy level subshell orbital electron kind of parsed out a little bit more. But on your periodic table, I would like you to label the blocks as either S, P, D, or F.
That would mean that.
So maybe like you could bracket them. S, P, D, and F. And perhaps you could even put in, perhaps you could put in a little key to yourself that's like, this is 4F and this is 5F. You might as well just write it in. And that this one starts with 3D. Just because it's a little weird. I'm going to point to a block. You tell me which block it is. Just make sure you're all good.
F. D. S.
Just that. Just helium. Here.
It could be in my car, but I
Okay, all right. Let me know if you find that.
it's like a lot of stuff.
Have you seen this periodic table?
Oh, you're not paying attention.
Okay. Into your notes, we're going to be putting a summary chart of all the orbitals and what they hold, and I think it'll be kind of nice to whittle it down. Okay. So the four types of subshells, S, P, D, F, some people don't forget.
Just some people.
Some people don't forget.
Why are they S, P, D, and F? Well,
Those are just their names. It means sharp, principal, diffuse, and something else. You don't need to know.
Can you tell us the F plate?
I can't remember. You can look it up.
She can remember. Well, wasn't something that we get our class going?
No,
Like
I
garbage.
honestly can't remember. Okay, so you have four different types of subshells, S, P, D, or F. How many orbitals for an S? P? D? And F. Okay. So what we're referring to here are these things. So S has 1. He has,
Throw that.
no, you do not, but I'm just doing it so you know. 1, 3, 5, 7. Yeah, F is very complicated. So you don't have to worry about it. Even in advanced chemistry, like when things bond, their orbitals might overlap and form like new big molecular orbitals. But even with that, you only deal with S and P, so it's not really a big deal. How many electrons could this have?
2.
Here?
6. 10. 14.
Always double the amount of orbitals. Orbitals. The amount of electrons are always double the amount of orbitals. Okay. What if you're like, I'm not gonna remember this chart. What's an easy way to remember how many electrons S has?
2.
It looks
What's
like,
an easy way to remember?
S looks like a 2.
Yeah. Oh, an S looks like a 2.
P looks like a 3.
Looks like a 6. Kind of upside down backwards.
Yep, there we go.
Okay, no.
D
What's,
looks like a 10.
how can I
F looks like
help
a,
you?
F looks like a 14.
How can it help you?
Count.
There's only two.
Use your eyes.
The S, there's 2 units.
Lexi?
2 different atoms across the end.
S has 1, 2. P has
6.
6.
D has 10.
D has 10 and F
F
is
has
14.
14.
Okay? Alright. Well. Also, if you're someone who like you just need some vocabulary ironed out or like in order, atoms have energy levels 1 through 7, and in the energy levels you have different types of subshells S, P, D, and F. Within the subshells, they have different amounts of orbitals 1, 3, 5 to 7, and then within the orbitals you have electrons.
Is that the energy level or is that just periods?
Both.
No, I'm not doing that about you. I was wondering what you were doing.
No, I wasn't. I'm thinking. Would someone be willing to share their address?
No.
Okay.
Why?
For the
Grant,
sake
I know
of
you're
an
1216,
analogy.
1216 Westerby Road.
Okay.
Grant,
alright,
here's
so
like
here we go.
that golden zone
Okay, so stop.
or something like that.
What we're going to learn next. You ready? Okay. What we're learning next is just basically a way of listing these in a way that is specific to each element. So I said, Avery, where do you live? He could say Nebraska. So look at this. Or he could say,
Firth.
he could say Nebraska, he could say Firth, he could say
Westerby
West
Road. Westerby.
Westerby, okay. I thought you were saying like West W. West W, and I don't know what he's saying. Westerby Road, or he could say,
1216.
yeah, okay, so these things are like more and more and more specific to the element. Okay, and so underneath this chart, what I'd like you to do is write something called an electron configuration. So like it's just more and more specific. Like he could tell someone, I live on Westerby Road, and that would get them pretty close. But as far as the specific electron, it would have to go all the way down, and you'll see how that plays out here. Okay, so electron configuration is just basically like a written list of electron location. And so we'll do 2 examples. Kelsey, will you choose an element? Any element, calcium.
Calcium.
That's pretty good. Is that why you like that element?
Yep.
Oh, nice.
See what is that?
Okay, and so everyone can locate calcium. It is an alkaline
Why?
earth metal. Nora, how many electrons? Okay, so we're gonna have to list the home for 20 electrons. So here we go.
Good
The first orbital that's filled in every atom, ever. 1s, and so you're gonna list 1s. So, and in the 1s orbital, how many electrons?
2.
2. So watch where you put this.
So square.
But it's not. What does the 1 mean? What is S?
Time travel.
And 2? No.
Electrons fill.
Yeah, electrons. Okay. So that's how this is going to look over and over and over again. So 1s2, that's how you say it. And then comes
2s2.
2s. 2. Let's see, what would come after 2s? Okay, and how many electrons would be inside? 6. Grant, how about after 2p?
3s.
Holding how many electrons? And Avery, after 3s?
3p.
What?
3p6.
Okay, and then Keely, after 3p6, what would be next for calcium?
4s. Squared.
2.
What's the square root of that?
4s.
Okay, so how you would say this would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Hmm?
Quite enough.
Why can't you just put the 1?
Hold on.
Potassium would be 4s.
Yup.
Yes.
Do people actually describe like electrons like that?
Yes.
How would you
And
You need to list all of them up to the point.
now it's not like what they'll say is like, well, since it's in this orbital, this is how it would react or something. Like they don't necessarily. It's not useful just to like spout this off, but yeah. Yes.
Why can't you just say the last one, since it's like understood that all of them go to there?
You can.
Sometimes I don't know. It's just not complete, I guess. But there is a way that you can do a shortcut that we'll learn very soon, like in the next 2 minutes.
Do we have to do that?
Okay, Harper, why don't you pick one other element?
Hydrogen.
Zinc.
Oh boy.
What's that hard to say?
30.
30.
Hey, if you would like to try this on your own, just don't look up here right now, okay?
We got a honey on that one. freight train can't stop most stuff.
Okay, first of all, looking at this answer here, what questions do you have? Yes.
That adds up to like over 30, doesn't it?
2 plus 2 plus 6 is 10, plus that is 18, plus 12 is 30.
Oh, never mind.
Right here instead.
Actually, and it always should add up to whatever you want the electrons to be, always. Okay. What other questions do you have?
Wait, what if it's like, are there gonna be some cases where like the last one isn't all the way full?
Yeah.
And you just put.
It'd just be like 3D.
So if, let's look, this one was zinc, but if it was copper, it would be 3D9 instead of 3D10. I'm glad you're all making sense of this. I see some nodding and like, yeah, get it.
So if you picked like one like over here, like below like a 3, would you have to like include like 4D until up until that?
Yeah, so you'd go like, or like let's say here where you had to go into the F's or something.
Yeah.
You'd literally have to go like 5S, 4F, 5D, 6P. You're not gonna have to do that.
6P4.
Right, yeah. So here's the shortcut. This is our last thing for today, okay? So if you would somehow connect this to your stuff you already have down underneath, aside, I don't care. But you need to title this Noble Gas Configuration. And once you're done with that, put your finger on calcium. And when you're ready, put your fingers on calcium. Ready? Okay, so what we're going to do is we're going to back the truck up. Keep backing up from calcium until you hit a noble gas. What noble gas is it? You all sure about that? Okay. And so you just
Wait, it could be krypton.
no, you gotta back up.
Are you backing it straight across? Or are you going
Backing it and then it's going around the hill back to Argon. I don't
It's
know.
like drawing a line.
You want a straight line or are you going back to Argon like the numbers?
Going down
The numbers.
Okay, yeah, Argon.
Okay. So here we go. The noble gas configuration for calcium. So you want to tie this directly to that. You write argon, and then you just pick up after that. Argon plus 4s2. So what it's saying is like this plus some more stuff.
So you just write the gas and then you put what's left.
Why the no? Because it's the full one, the last full.
The last full energy level.
That makes sense.
Okay, so find zinc.
Right, press
Oh my gosh. Okay, find zinc. You got it? Fingers on it? And you gotta do beep, 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 beep. So back up. Back it up. Aaron, what noble gas will be most recent?
Argon.
Argon again. So AR. Melina, what would come, if we started at AR and we're trying to get to zinc, what comes next? Okay. And then Dylan, how about after 4s2? We're trying to get to
3D.
3d, 10.
So will you always go backwards, like even if you're like 2 away from it?
What if you're at a noble gas?
Yeah.
So then you just like.
Actually, we drew
Then you go all the way back to the earlier one.
We did it
For
backwards.
real?
Why can't you just write the noble gas?
Yeah.
We did it backwards.
So if you're on a noble gas, you have to go all the way back to the last one.
3D10 for us.
So if you're at argon, it's
Remember
going
why
all the way back
Because
to neon.
we get away with the smallest level first.
It would give this one away
Yeah.
first.
Wait.
Okay, that's it. Yes.
So if you're at argon, you have to go all the way back to
Neon.
neon.
What about helium?
Right, neon plus 3s2, 3b6.
I feel like.
Okay.
Wait, what? How do you write helium?
This year.
or highway?
I think that's short enough. Like the whole reason is to do shortcuts. So just write
Does that
1s2.
just be-
That's
So it just be 1S.
2 or 1s2.